Hello everyone, in this video we go over calculations that involve conservation of mass. This is the idea that the total mass of the reactants always adds up to the total mass of the products. We'll also look at a practical that involves conservation of mass and some calculations that are often on your exam paper. So let's get straight on with looking at some calculations. Let's look at some examples of conservation of mass questions. For all of these questions, we need to remember the total mass of reactants on the left of the arrow equals the total mass of products on the right of the arrow. In example 1, calculate the mass of HCl that is made. So on the left, we can see we've got 2 grams plus 71 grams, which equals 73 grams. So that means on the right, we also have to have 73 grams. So it's simply 73 grams. And we got there by adding up the reactants on the left. Let's look at another example. Calculate the mass of O2 that reacts with the Na. So on the left needs to add up to what's on the right. On the right, we've got 128. So the missing number we can find by subtracting. We start with 128, take away 96, and that gives us 32 grams. So this time we had to find the missing number by subtracting because we want to make sure that everything on the left adds up to everything on the right, and we can check if we're correct. So if we put in 32 grams here, and then add these two numbers up, 96 and 32, that will come to 128. So the reactants on the left is equal to the mass of the products on the right. Now it's your turn. So find a piece of paper and a calculator, have a go at these questions, and then resume the video when you've had a go to check if you got them right. So the answer to question 1, the mass of the products on the right must be 48 plus 32, which is 80 grams, because that's the mass of the reactants on the left. Question 2, this is where we need to subtract. We need to find the missing number here. So 96 plus something adds up to 128. So to find the missing number, we do 128, take away 96, and that is 32 grams. And finally, for the last one, once again, we've got to find the missing number here. So we would do that by starting with 126, take away 108, and that equals 18 grams. And once again, if we were to put 18, if we get rid of that, and if we were to write 18 grams in here, we can see that everything on the left, 108 plus 18 adds up to 126. And on the right hand side, the products, we've also got 126 grams. In this practical, we're going to burn a small piece of magnesium and see what happens to its mass. Now normally when we burn something like a piece of wood, we'd expect it to get lighter. But when we burn the magnesium, it actually will increase in mass because the magnesium atoms are going to join with oxygen atoms from the air to make magnesium oxide. So those extra oxygen atoms that it's joining to will increase its mass. So first of all, I've got a small piece of magnesium ribbon, and I'm going to burn it in this small pot called a crucible with a lid on top. So first of all, the first mass I'm going to record is the mass of the crucible and the lid empty. I'm then going to coil up the piece of magnesium so that the air can still get to the magnesium and the oxygen can react with it to make that magnesium oxide. I'm going to put the magnesium in the crucible, put the lid back on, and now I'm going to take down the mass of the crucible and the lid and the magnesium. So at this point, I can be ready to start burning the magnesium. Instead of using a gauze on top of the tripod, we've got this clay pot triangle so that the crucible can sit down in there and we can get maximum heat underneath the crucible. So let's get on and burn the magnesium. So now we can start to see the magnesium reacting. We're getting a nice white glow from the magnesium. Don't know if you can see it any better if I do that. Maybe that's not a good idea. So the magnesium is burning away quite happily in there. Every now and then we take the lid off to let more oxygen get into the reaction. Remember, the magnesium is going to join with oxygen to make magnesium oxide. Now you can lose some product if you lift the lid off too much and some of it spits out. You would lose some of your magnesium oxide onto the table. That will give you a lower reading than you expect when we come to reweigh it. Also, if you don't keep lifting the lid on there, you're not letting more oxygen get into it, so that would be another reason why you would have less magnesium oxide produced, because you're not letting enough oxygen in. Okay, so that should be burnt now. If we have a look now at what the magnesium looks like after the reaction, the silvery magnesium metal has turned into the white powder that is magnesium oxide. The last thing we need to do is to reweigh the crucible and the lid and the magnesium oxide that is now inside. So I need to be careful, this is still very hot. That's still got the white powder, the magnesium oxide inside. And we take the mass of that, and then we're going to use all those recordings of mass to do some calculations. Let's see what we can work out from those results of the practical. So in an exam you could be provided with these results. The mass of the crucible and lid is 27.86 grams. Then we've got the mass of the crucible, lid and magnesium, which is 28.03 grams. And then after it's been burnt and changed into magnesium oxide, the mass of crucible, lid and magnesium oxide is 28.21 grams. So pause the video now, have a go at the questions and then resume the video to see if you got them right. Okay, so calculate the mass of magnesium. Well, we need to have the mass of magnesium crucible and lid, which is 28.03 grams. Take away the mass of the crucible and lid, so the empty pot in other words. So take away 27.86 grams. And the answer to that is 0.17 grams of magnesium. Okay, then it says calculate the mass of magnesium oxide. Well, we do it the same way. The mass of the crucible, lid and magnesium oxide is 28.21 grams. So we need to take away from it the mass of the container and the lid. So take away 27.86 grams. And that comes to 0.35 grams of magnesium oxide. Then on the next question, use the following equation to calculate the mass of oxygen that reacted with magnesium. So we need to put those numbers under the equation like we've been doing in the questions earlier. So we've got 0.17 grams of magnesium, and that's going to turn into 0.35 grams of MgO. So we want to find the missing number. We do that by subtracting. So 0.35 take away 0.17, and that would be 0.18 grams.
Okay, so why might the mass of magnesium oxide be less than expected? So once again, pause the video, have a think, try and come up with 2 reasons. Remember, magnesium oxide is the product. So you could say that the lid may have been left off, allowing some magnesium oxide to spit out, so you're losing some product. Or you could say the lid may not have been lifted up often enough so that more oxygen could get in to react with the magnesium. So if you're restricting the supply of oxygen, the magnesium's not going to combine with it as much to make the magnesium oxide.
So there you have it, everything you need to know about conservation of mass calculations. If you found the video useful, please remember to like and subscribe. Thank you for watching.